Accurate and trustworthy thermal testing doesn't just depend on high-quality instruments, it depends on how well those instruments are maintained over time. Even the most robust systems can experience gradual changes in performance due to normal aging, repeated thermal cycling, environmental shifts, mechanical handling, or software and firmware updates. These changes often are subtle, and they can go unnoticed until results begin drifting outside expected ranges. That's why proper calibration and regular verification are so important. Together, they protect data integrity and ensure confidence in every measurement you make. Instrument calibration is the process of adjusting a measurement system so its output aligns with a known reference. For example, in our HFM series, a commonly used reference material is NIST 1450E, a certified reference material from the National Institute of Standards and Technology, selected for its stability and traceability. Calibration directly impacts both accuracy and repeatability. A properly calibrated instrument produces results that fall within a specification and can be confidently compared across samples, tests, and even laboratories. Verification, on the other hand, is the process of testing a certified reference material against the calibration to confirm the instrument is still performing as expected. Verification should be performed regularly, especially after environmental changes, heavy usage, or software updates. If a verification test fails, that's a clear signal that a recalibration may be needed. Always perform a verification test after calibrating a unit and continue verifying periodically during routine use. Verification confirms that the calibration worked correctly, and it helps identify early signs of drift. Heavily used instruments, or those exposed to challenging materials, may require more frequent checks. Tailoring verification to your usage helps balance accuracy, efficiency, and downtime. Ambient temperature, humidity, and airflow all can influence sensitive thermal measurements. Keeping your lab environment stable reduces noise and improves long-term measurement consistency. If environmental conditions change significantly, your calibration may no longer be valid and recalibration may be required. Sensors and accessories are often the most vulnerable components of a thermal testing system. Avoid excessive bending, pulling, or contamination, and inspect components regularly for wear or damage. Proper handling helps preserve calibration integrity and extends your instrument's lifespan. Maintaining records of test conditions, verification results, software changes, and unusual observations makes it easier to track performance trends. This documentation provides valuable insight in troubleshooting and determining whether recalibration is necessary. Software and firmware updates can improve functionality, but they may also affect data processing. After any update, it's good practice to run a verification test using your reference material to confirm performance remains consistent. Reference materials are only reliable if they're properly stored. Keep them clean, dry, and protected from contamination or extreme temperatures. Proper care ensures they remain a dependable benchmark for calibration and verification testing. Instrument calibration isn't a one-time task, it's an ongoing process. It starts with proper calibration when the unit is received and continuous regular verification to ensure that calibration remains valid. By taking a proactive approach, monitoring performance, controlling environments, handling equipment carefully, and verifying regularly, you can maintain confidence in your results, extend your instrument life, and minimize unexpected downtime.